tonight. So tonight we are going to be doing a webcast on the Hacker's Apprentice, which is an escape room that I built in my house with lots of Internet of Things and things like that. But before we get going, I've got a couple things to show you. One of them is I've got a game. I'm curious. You guys should have in your go-to training console, you should have a chat, and you should have a questions. I think we're going to be using the questions window for you to respond back to me to a bunch of questions as we go through, and we'll also be using this to play the game this evening. So go ahead and look through Go to Training. You might have to click on the little orange X and then scroll down through there, and you'll see the questions. You'll see chat. We're going to use questions. If necessary, there's a little pop-out window that you can pop that out and move it over to a second screen, or move it to some place where it's not in the middle of the screen so that you can see the screen and the width box as necessary. But let me just ask before, yes, exactly, right there. I got the question here. Yes. Before we go through and do this, let me ask, how many people in the room have seen my pre-show of songs written in Python? If you've seen that, send me a message and let me know that you've seen it. No one has seen my pre-show for songs written in Python? Okay, since no one has seen my pre-show for songs written in Python, then that is where we will start out. We'll start out with songs written in Python, and then after we go through the songs written in Python, then and we're a little bit closer to the start of the event, then I'll go through the new pre-show of movies written in Python. All right, so here we go. This is songs written in Python. The idea is, well, I've written some Python code that is intended to uniquely represent or give you an idea of a song, either a lyric from a song or a title of a song. So I'm going to show you the Python code. I want you to read the Python code and tell me what song I'm talking about. Okay. All right. So your first song written in Python is this. Go ahead and type the name of the song into the questions window for this. What is the name of this song written in Python? Bonus points for the artist that goes along with it. \n has special meaning in Python, and well, most computer programming languages. A \n is a character that has special meaning in Python and other languages. So in the questions window, type this. Type, what is this song that we're talking about here? It is the new line character, also known as pressing a certain key on your keyboard will generate that. So what song title? Enter is half the song title. Enter is half the song title. What is the other half of the song title represented by this slide? I can't sing it, right? All right. The name of this song is Enter Sandman. Enter Sandman by Metallica. Enter the Sandman by Metallica. Okay. All right. We're going to try another one here. Another song written in Python. What is the name of this song written in Python? We've got a while loop here. And the while loop says while true, which means it's going to stay in this loop and it's going to print the word young to the screen. What is the name of this song? I need some guesses. I can't advance the slide until someone gets this one. Maybe we just don't have enough people in the room. Maybe there's actually nobody in the room. There's 6 people. We went from 10 to 6. You're not able to see the code or hear the song. You're not able to. Oh my goodness. Well, that explains it. The slides are not advancing on here. Hold on a minute. Let me click a button. Thank you so much for the question. All right. Can you see that now? All right. So this first one's going to be easier now. Okay. Okay. Let's try this again. What is the following song written in Python? Any guesses to this one? I went back to the beginning. All right, so now Enter Sandman. Yeah, Enter Sandman makes sense now. Yes, okay, it does help if you can see the slides. I will concede that it is a much easier mode of the game if you can actually see what I'm presenting to you. All right, that one is Enter the Sandman by Metallica. This one, what is this one? What song is represented by the Python code on the screen? While true, print young. Not indefinite. This is an older song. Okay, this is a 1980s, maybe 1980s, which of course is the best year decade. It is Forever Young. Forever Young. Well done. And Brad got that one. Brad got this one. Forever Young. Well done, Brad. Okay. The next one. Can you identify this song written in Python? There we go. Brad got it. Brian got it. This one is Don't Stop Believing by Journey. Excellent job. All right, so you get the idea. These are going to get a little bit harder. Okay, a little bit harder. How about this one? It's a pretty recent, let's say, pop rock song. In Python, if you have a dictionary or a JSON object, you can use the get method to retrieve a value from the dictionary. In this case, I'm trying to retrieve the value in the dictionary with a key of my. And it returns back hashtag pipe. Any ideas? Any guesses? Excellent job. This one is excellent job. Ali got that one. This one is by Weezer. I got my hash pipe. Dum, 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 dum. All right. Hash pipe. Get hash pipe. All right. How about this one? In the random module, chooses a random number between 0 and 1, a floating point number, so 0.2, so a floating point real number between 0 and 1. And if it's greater than 0.5, this will call a function. But there's only a 50% chance. So, excellent job, Brian. Brian got Call Me Maybe. Call Me Maybe by Carly Rae Jepsen. Well done. Okay. How about this one? Oh, this is 1980s again. The date time function in Python is, well, how you can generate a date and time. And you can pass to it the year, month, and day for the item that you want to create. And in this case, we're using the date time now function to retrieve a date, retrieve the year, current year, and subtract 1 from it. So what this will print is what? What song are we dealing with here? Brad got that one. Well done, Brad. Wham's Last Christmas. Right, so we take the current year, we subtract 1, and then December 25th of last year. This was Last Christmas by Wham. Excellent job. Well done, Brad. All right, so this one is a bit harder. So I'm giving you the genre and the year. This is pop music 2010. Pop music 2010. This one's really hard. It's rare that someone gets this one. Okay, so I'll begin explaining it and look for an answer. So in here we have in Python what we call a list comprehension. A list comprehension is where we dynamically build a list based upon, well, other values that are in the list. So here we're building a list that contains I for each I in this list called world, but we're only going to put I in the list if the gender is female. Then we're going to take the length of the list of all of those, all of the I's in the world that have a gender of female, and it's equal to 1. Equal to 1 returns true. So any guesses on this one? Woman of the world, that's a good guess. This one's Rihanna, the only girl in the world. The length of the list of all of the people in the world that are females equal to 1. So it is the only girl in the world. All right, this one. All right, in Python, objects, also known as classes, if you would like to see what's in them, you can do a dir, called a dir function, and it'll show you all of the things that are in that class. And here, we are asking it for a list of all of the things that are in class today, where we see these items. This one is Pearl Jam. Jeremy spoke in class today. Pearl Jam's Jeremy. All right. Let's see. How about this one? This will be the last one we do, and then we're going to switch over. We're going to switch over to our movies written in Python after this. But this one. We import the time method, and we import the random method. We then say we have a list of destinations: Staten Island, Manhattan, Brooklyn, and Queens. This is a Python list here. So then, while true, or forever here, we're going to look to see if, when we choose one of the random items out of this list of destinations, we're going to choose one random item out of this list. And then we're going to take the item that we've chosen, and we're going to look to see if it starts with the letter B. Excellent job, Brian. If it starts with the letter B, we're going to call the time.sleep method. So this is no sleep until Brooklyn. No sleep till Brooklyn by the Beastie Boys. So we're choosing a random value. We're going to stay in that loop forever, not doing anything until the random item is Brooklyn, at which point we will sleep. Yep. Excellent job, Brian. All right. So Let's stop with this one. I'm going to switch over now because we got 12 minutes left, and I want to pull up my new pre-show, the movies written in Python. Okay, so that I will give you the year for the movie. You have to tell me the complete title. For this first one, I need the complete title of this movie. What is the complete title of this movie? Here we build a Python list that has items in it. The name of this list is Avengers. Then we call Avengers.pop. Pop will return one of the items from the list, taking it off the list. It does return, as Brian has indicated, it does return the word Captain America, but there's more to that title, and it is relevant to the code you see here, because Captain America is the first Avenger. Excellent. Brian, Brad, this one is Captain America, the first Avenger. All right. How about this 1952 song? 1952 song. Excellent, Brad. Singing in the Rain. Got that one pretty quickly. Here, let me just move this up a little bit so it stops cutting off my head. So this one is Singing in the Rain. Here we build a string X that contains the rain. Then we have Y that is the word singing, but this colon, it's the word singing backwards, but colon, -1 will reverse a string, so we end up with singing forwards. And then we take the rain, X, and we insert Y right into the middle of it, so we get singing in the rain. All right. How about this 1975 movie? 1975 movie. Here we import the sys function, which lets us check the version of Python we've got, the requests module, which lets us interact with web pages, and RE, which lets us do regular expressions. We then print sys.versioninfo.major, which prints the version of Python, and Brad got this one. That is Monty Python and the Holy Grail. So the version of Python we're running is Monty. We go on a quest by retrieving the text from King Arthur's court, and then we search for the Grail inside of the quest, and we do find. You can see here the results of the Grail are found in position 956 in the results. So this is Monty Python and the quest for the Holy Grail. All right, how about this 2011 movie? 2011 movie. This 2011 movie, we are using the uncompile program, and we're passing it, well, some byte compiled code from our Python. So this, when you have a Python program and you've imported it as a module, or you run it through a byte compiler, it ends up creating a .pyc, which if you were to look at it, it's just binary. It's a binary interpretation of the Python code that has been created to optimize for the interpreter. So here we are running this Python program through the uncompile program, which gives us back the program. And here we can see the program says cast equals Jake Gyllenhaal, Michelle Monahan, and Vera Farminga. Any ideas? It is source code. Excellent. Right, it gives you back the source code. We uncompiled the byte program to get back the source code. Very well done, Brad and Ali. All right, how about this movie from 1999? Wow, 99, was it that old? All right, here we go. We've got a list of items. Then we try and slice out one of those items, but it actually doesn't exist in the list. So we get back an error. List of items is important. What kind of items are those? What do you think of this one? Oh, I got some answers here. Brian got it. It is the sixth sense. The list there is sight, hearing, smell, taste, and touch. And when we slice out something, or when we pull an item from a list in Python, this is position 0. This is position 1, 2, 3, and 4. So of our 5 senses, the last sense is in position 4. So this would actually be pulling the 6th sense from that list, which, well, in this case doesn't exist, so we get an error message. But this is The Sixth Sense with Bruce Willis. Excellent job. Well done, Brian. All right, how about this one? 1991 movie. Once again, the context of the list and what it means is important here. We got a fine, we got timeout, you got an electric chair, you got imprisonment. Then we're going to map the function, take a string and convert it to all uppercase across this list of items and generate a new list of items. So what do we have here? Any guesses on this movie written in Python? It's not Drive, it's not The Green Mile. This is, oh, capital punishment. Those are all punishments in the list, and we've converted them to all uppercase, making all capital punishments. Okay. How about this movie written in 1993? Released in 93. I don't know when it was written. Is the name of this movie in 1993? Brad got this one. Well done, Brad. The Last Action Hero. So here we have a list of action heroes containing all the greats: Sylvester Stallone, Chuck Norris, and Arnold Schwarzenegger. And we take the last item, position -1, would slice out the last item from this list of action heroes, giving us the last action hero. All right, well done, Brad. All right, how about this movie, 2002? What is the name of this movie, released in 2002? We have some complex Python code here. Here we create a custom error type, right? A custom exception that can be raised by this program. The name of this exception is UCAN. And what it's doing is it's going to raise an error if it's going to raise an error with a message of identity incorrect. And Ali got this one. This one is catch me if you can. So when we handle errors in Python, we do it with what's called a try except block. And the purpose of the try except block is to catch errors and handle them. And so here we have a try except block that is trying to capture if an exception occurs when it calls this me function up here, which looks at the identity of this thing, looks for the identity being pilot. And if the identity is not equal to Frank, it always raises this error called UCAN. And that will catch, this try except block will catch the me UCAN error. So catch me if you can. Catch me if you can. All right, Leonardo DiCaprio and Tom Hanks. Well done, Ali. All right, 1990. What was this movie released in 1990? 2 lists. Then we map this join function across the 2 lists. We create a list with the 2 things combined. What is this movie? What is this movie written in Python? If you are just joined us, you can type your answers into the questions window. Type your answers into the questions window. Okay? It is not Teen Wolf. you're just joining us, you can type the name of this movie into the questions window. It is, well done, Brad. Brad got that one. It is Dances. This is the list of dances: the Hustle, the Twist, the Charleston, Renegade, and Salsa. And this is a gray wolf, a werewolf, a teen wolf, a boy who cried wolf, big bad wolf. This is a list of wolves. So this is, when we join them together, we get Dances with Wolves. Dances with Wolves. Yes, it is Dances with Wolves. Yes, there is going to be a test, Stephen. All right, Dances with Wolves by Kevin Costner. All right, our next movie, written in Python, released in 1999, is we import the NumPy module, which allows us to create, we'll call them grids, arrays of arrays. And here we create a 10 by 10 array of arrays. And then in position 1, we put the 1. In position 3, 1, we put Father, Son, Holy Spirit. In position 5, we put Smith. And in position 4, 2, we put, well, some crypto. What is this movie written in Python? It's not John Smith. What is another name for an array of arrays? There you go. Thank you, James. This is the matrix, right? We create a 10 by 10 array of arrays, otherwise known as a matrix. And we put Neo, who is the 1 in position 1. We put Trinity, who is 3 and 1 in position 3, 1. We put 5, 5. Agent Smith goes dead in the middle. And we also put Cypher. We put Cypher in the matrix. So well done, James. This one is the matrix. All right, how about this 2010 movie? What is this 2010 movie? If you're just joining us, you can type the name of this movie that has been written in Python into the questions window. This is the pre-show. Our show will be starting in just a minute. All right, it is the A-Team. Here we have a dictionary, a Python dictionary. Dictionaries are made up of keys and their associated values. So here we have the key of C, Cowboys, the key of R, Redskins, key of A, Astros, key of B, Vikings, and then we do a teams.get to retrieve the A-Team. It retrieves the A-Team. So there's our A-Team. How about this 2017 movie? 2017 movie. Excellent, Stephen. Stephen got this one. This is Ghost in the Shell. Here we open up a copy of bin bash, the shell for our Linux operating system. We read it in as a binary file, putting it into a big byte string. And then we look to see if the byte string Casper, which is a ghost, is in our Linux shell, and it comes back true. There is a ghost in the shell. Well done. 2004, what is this 2004 movie? I believe this is our last one. Last one. 2004 movie. I'm going to import a couple of modules, date, time, and random. I'm then going to create a function called getFirst, which takes in these two things, and then it returns the minimum one of those two things. Excellent. Brad comes in with the win. So this is going to return the first of these two things, and then for a range, for I in range 50, so 50 times, we will choose a random date for X, a random date for Y, and then we will print what happens when we call getFirst, which this will print 50 first dates. 50 first dates. Excellent. Well done. All right. I think that was it. That's all of our movies written in Python. All right. So I hope you enjoyed that pre-show. Thanks for coming out this evening. My name is Mark Baggett, and didn't come to see movies written in Python, came to talk about the escape room that I built in my house. So welcome to the main part of this evening's event. We're going to be talking about the Hacker's Apprentice. And the Hacker's Apprentice is, well, it's a theme for an escape room that I built inside of my house. A little bit about me. My name is Mark Baggett. I'm a Senior Instructor for SANS. I'm the course author for SANS SEC 573, which is Automating Information Security with Python. I do have a master's degree in Information Security Engineering. I was the 15th person to get my GSE through SANS. I was former CISO for many years, and most recently, for the last 10 years or so, I've been working with the Department of Defense and standing up many of their training programs. My very thank you to the community. My name does appear in the source code for Metasploit 7 times, even though I've never actually contributed a module. It's just that other people have written modules based upon different tools, techniques, and things that I presented at conferences, and they were kind enough to give me credit for those TTPs. So thank you to the community for, well, putting my name in Metasploit. Tonight we're going to be talking about an escape room that I built in my house, and it's a combination of, well, different IoT devices I've got and Python code, and it built a nice escape room out of this process. So at this point, I built this escape room probably a year and a half ago, almost 2 years maybe, and it took me about 5 hours to put it together initially, and I've just had hundreds of hours of fun with it at this point. We have many different teams, different information security people who've come to Augusta, Georgia, where I live, have come by and done the escape room. It's been a lot of fun for me, and with all of us, well, many of us still sequestered in our homes, I wanted to talk about how you could take some Python code and have some fun and games within your own house. So why did I do this? Well, Ed SCOTUS is the root of all evil, right? So I went to DerbyCon and I saw Ed's awesome keynote talk there on the Internet of Things, voice control, AI, and office automation, building your very own Jarvis. And in this, he talks about all this home automation that he does, where he controls just about everything in his house from through voice automation, through custom Python code. And I'm looking at the custom Python code, and I'm thinking, well, this looks pretty cool. I should probably actually spend some time playing with this. And then I did. And then the next year, I come back to DerbyCon, and Ed gives an update. Further adventures in smart home automation. Honey, please don't burn down your office. And Ed does this awesome keynote, and both of these keynotes are still available on YouTube if you want to check them out there. Ed does a great job in explaining what he did in his house. And so I saw the second presentation. I'm like, all right, that's it. I'm gonna go home and I'm gonna learn some of this home automation stuff. So I go home and I'm sitting at my kitchen table, and I'm reading about how to do home automation, and I'm reading about this new module called HomeAssistant. And really, most of this talk, we're going to be talking about HomeAssistant and how I use HomeAssistant to tie together all these things, because it does all of the heavy lifting for you. So I was reading about HomeAssistant. I got really excited about, all right, I'm going to do some cool home automation. All these ideas are coming through my head. My wife comes in, she says, Mark, said, we're going to have some friends from church over on Friday night. I need you to come up with a game or something for us to do on Friday night. And this was on a Wednesday, and I'm like, okay, I'd really like to do this home automation thing and not come up with a game or something like that. But wait a minute, maybe I can put the two together. And so the escape room was born. I had 2 days, 48 hours. It took about 5 hours of time to put together, well, most of the stuff that you're going to see tonight. Because HomeAssistant really makes this thing easy. It pulls together all of the different components for you. It's a free module that you can download. It's got a homepage of www.homeassist.io. It's got graphical user interfaces. It's got command line interfaces. It can talk to different types of home automation that you've got inside your system. It talks to all of the different light switches, thermostats, and other things you might have in your house that are talking about. As a matter of fact, anything that can talk on a wireless network, you can integrate into HomeAssistant, and most likely someone else has already done all the heavy lifting for you. The key to understanding HomeAssistant is to understand this architecture over here on the right. So it's got built into it a state machine which tracks the current state of every electronic device. So it knows that this light is on, this switch is up, right? This particular sensor is set in this way. The sun is up, the sun is down. So it's got all these different sensors that it tracks in the state machine. It's got an event bus where if there's any changes to the states of any of those lights or any of those devices, it always puts a message onto the event bus. And then all of the different devices that you got in your house, light switches and so forth, they all subscribe to the event bus. So they are told when different things happen. These different components can also publish services. So like a light bulb can say, hey, I can be turned on and I can be turned off. And so with that, we can write code that says, all right, when you see the event that says the switch has been turned on, now go over to the light bulb and call its turn on service so that it can turn on. And all of this is done with, well, either some very simple code or even without it through web interface. So you can do many of these things without coding. So I downloaded HomeAssistant and put it on my network, and I let it discover all of the devices that I had on my network. And there were lots of things that I expected it to find, like, you know, Alexa, Google, Siri, any type of home automation device or smart device I had on my network. I expected it to find that. I expected it to find my Apple TVs, IP light bulbs, IP-enabled thermostats, cameras that you have on your network, or IP-enabled locks in your house. I expected it to find all those things. But when I ran the discovery, I was, well, a little surprised, I'm ashamed to say, as an InfoSec professional, at all of the different things that it discovered on my network. It found and made available for automation all of my networking gear that I have in the device through plug and play. You're like, why would you want to use networking gear? It turns out that that's actually really useful. It finds all the services that were running on all of my computers. So like if a machine in the house had an iTunes library, I could consume the videos and the songs that were in that iTunes library as part of HomeAssistant and, well, do things with them. Broadcast them to, well, the televisions that I have in your house. So any IP-enabled televisions, it discovers those and it'll interface with those. Discovered Blu-ray and DVD players in my house that have no networking capabilities. So there's no Bluetooth on them. There's no network interface on them. They are just devices that have HDMI out that plugs into my television. I'm like, what? How in the world did it find my Blu-ray players that aren't on the network? Turns out that it discovered my Harmony remote control, which is on the network, and it read its configuration. And because it can interface with the remote control, it can use the remote control to turn off and on the different devices that the remote control knows how to use that, well, aren't even on the network. It found my sleep number beds. And it knows, well, whether I'm in bed, whether I'm out of bed, it knows my sleep numbers, right? It knows way too much information about it. I found my security system can turn off and on my alarms, which is a little scary. We'll talk about that in a minute. And all of this stuff, after it finds all these things, it provides you with an awesome pre-built web interface that you can go in and can control all of these different devices. So here you can see in this web interface, it knows when the sun is up or down. It knows when these people are home. This is actually based upon many different services that you can have in there, but one of the ways it can know is your home is it can inspect your ARP cache, right? It can use that. Remember I said it discovered my networking devices? I can tell if this is the MAC address for my phone. And if that MAC address ever appears in the ARP cache on my wireless network, then it knows that I'm home, and it can use that as a tracking mechanism to, well, do things based upon the fact that I'm home. It knows the humidity and temperatures if you've got any of those types of devices. So all of these, you got some components that appear up here to give you information, and then you can control them with switches on the main page. And that's just the mobile interface. There's also a whole public interface. But really the power of HomeAssistant is, look at the numbers inside these boxes. There's 30 different alarm systems it talks to. It talks to 12 different cars when they're sitting in your garage, climate control systems, environmental systems, health web pages, things like that. It's insane what this thing talks to. If I just go out to their web page here, you go to integrations, right? You can see all kinds of things that it talks to. So let's just come down to, I don't know, fans, right? Here's all of the different types of fans that it can talk to on your network. If we go to health, right, we can see things like there's the sleep number beds. It'll talk to a COVID-19 database, so it'll monitor online COVID-19s, and it can take automation, have automations that happen when it sees certain devices. Right? We got transportation, where it can talk to different, well, train service. You can look at this train service. You can call yourself a Lyft or an Uber when certain events happen within your house. So it's got extensive integration into all kinds of online services, as well as just about every type of device that you want. Remember, I just saw this posted recently. This is the component that they're about to commit to it, which will track the status of your Oral-B toothbrush. You know, your Oral-B toothbrushes are now wireless enabled, or Bluetooth enabled, and it will know your toothbrush's state as to whether or not it's idle, running, whether or not you've had a daily cleaning, tongue whitening, whatever those different settings are of the brush mode in your while. So it is well, extensive, to say the least, in the different types of devices you can integrate into this thing. Okay. All right. So all kinds of integrations with this thing. And with each of the integrations, it's got pre-built widgets that'll appear on websites that you can use to, well, track the state, to change the state. So here's a thermometer. I can come up here and I can slide this around to change the temperature in my house. And all of this is designed with zero coding, right? The idea is that the average consumer can stand up a HomeAssistant, well, either Raspberry Pi or run it on a Docker, or put it on any laptop that they have on their system that can run Python modules, and then they can begin using this to do home automation. It also includes some really cool logging, right? So here, if I just go into logs, here I can see downstairs thermostat occupancy. So this is it detecting the greens are when someone was in the downstairs, and well, the reds are when nobody was in the downstairs. Here's tracking based upon individuals, so I can see when Mark was home or away, so I can go back historically and see when people were either in rooms or home. The things that it doesn't detect, right? It's got hundreds and hundreds of integrations, but if it doesn't have what you need, you can create custom integrations. So I have this weird intercom system that came built into my house, where I've got little audio panels that are intercoms that are inside the different rooms, and it's by Legrand on Q. And there was no Legrand on Q integration with HomeAssistant out of the box, but they provide easy to use templates that you can download their sample code, and then with a couple of modifications to code. Here you can see I create a little program called Media Player that interfaces with my Legrand media system. It's 200 lines of code. Of those 200 lines of code, I probably wrote 30 of the lines, and the rest of it was all templatized. And now this thing supports custom components that I have in my house that, well, just aren't common elsewhere. Now the way you configure this is through YAML, right? Yet another markup language. And you can see over here on the left an example of some YAML code that is creating these switches over here on the right. So these are all switches that I can use to turn off and on different states in the house. So over here I can see an input boolean, which is the tag for each of these switches. I can see I have a switch named automation lights, which the value of it is automation lights. The name is light automation, which appears here. And its initial state is on, and then I can define the icon that is associated with it. So by just creating each of these, all of these little switches now appear in my web interface. And I can go in there, I can click the switch, and it'll toggle back and forth. Now, when it toggles back and forth, what it does is it puts a message on the event bus that something else can then consume and take actions on it. But by itself, just creating these switches really has no action other than, well, it creates some things that happen on the event bus. Now, you see this one that says some password, right? That I have a switch whose name is a password. We'll come back to that and we'll see where I use that later in the challenge. Now I've got all those switches, right, that are just on there that I can go into the web page and I can toggle them. But for an escape game, I don't want people to go to a web page and start clicking on buttons, right? I want them to just be able to do things. Well, those switches are all controllable through Alexa or through Siri or Google Voice, whatever your system is, through this thing that they call the Philips Hue emulator. Right? Philips Hue is, Philips Hue makes all the light bulbs, the IoT light bulbs that you have in your house. And it has this Philips Hue hub that you have in your house that controls all of these lights. Well, Alexa, Google, and Siri, they all integrate in with Philips Hue because it's just a widely used product. Well, HomeAssistant will appear on the network as a Philips Hue bridge, which means that, well, Alexa, Siri, and all these other devices, they see it as, they see every one of these switches that HomeAssistant provides as a light bulb that I can give a voice command, turn on the escape game. And this will tell, I say that to, say, Alexa or Siri. It then sees a light bulb that it turns on, flicking this switch. So when it does, if I was to say that, it would then flick the switch to on, and the switch would move from the left to the right. And when that happens, it then puts an event on the event bus that I can consume and react to. Now, the way you react to those is through triggers, conditions, and actions. So the trigger is going to be the thing that, well, we're looking for in the event bus. Conditions are going to say only execute for this, of that, if that event occurs and these other things are true, and the action is what you want to do. I know it's really small to zoom into each one. So this is the trigger, right? In this case, I've got a trigger that says, look for in my downstairs thermostat and check the occupancy. And when that changes, when the state changes from unoccupied to from unoccupied to occupied, then I want to, well, check some conditions and then take an action. Here's my condition. I only want this the action to occur if that triggers and device tracker for Mark, right? The thing that says, oh, Mark's MAC address is on the network, says that Mark is home. If those two conditions happen, and the sun, it's before sunset and after sunrise, so the sun is up, then call a service called a media extractor service to tell it to play some media. And it will play the media on, well, my Sony television. So it'll turn on the television. If the television is off, it turns it on. If it's on some other channel, it stops and it flips it over to the service. And then it'll play this YouTube video on the television. So if I walk into the home, if somebody's in the kitchen and I am home, or in the living room and I am home, then it will play this video. It would be one example of a script that, well, I wouldn't leave on because it was annoying, but it's just a demonstration of the kind of things you can do. Now and also call this and execute this other script called escape welcome. So in addition to configuring it through the web interface, you can also configure this stuff through YAML. So I could create a script here, and here you can see an automation. The name of this this automation is called Goodnight. And what this one does is the trigger is when there is a when my sleep number changes its state to on. The sleep number on state is triggered when, well, when we lie in bed, right? So when I lie in bed, then the sleep number state goes to on. I have some conditions set around it, and it says if all of the devices in my house, so my wife's phone is home, my phone is home, my children are home, then if all of the devices are home and it's after 9 o'clock, then turn off all the lights in the house. Turn all the lights off and go into my alarm panel and arm the alarm panel. So it'll arm the security system in the house if it's after 9 o'clock and all the devices are home. All right, so that's my good night script. This is my great night script. If we're in bed and the kids are not home, then set the lights in the bedroom to 50% and tell Alexa to play the romantic playlist in the bedroom. Yes. Okay. This is not a good idea. This is actually not very effective because, as it turns out, the effectiveness of a romantic gesture is inversely proportional to the amount of automation that's being used, right? Up here at the top is writing poetry, right? No automation whatsoever. Then scheduling your gifts, like your anniversary gifts automatically, FaceTime on your anniversary, robots for dinner, way down here on the bottom of the list is having Alexa tell your significant other that it's time for whoopee, right? It just doesn't work out for you in the past. So that's not necessarily a good script, but it's a cool little script to write. Okay, All right, so now I've got these scripts. And this was with no code. Everything you saw so far, all that automation was no code whatsoever. So I can say, Alexa, turn on the escape game, and it will flip the switch, and then I can have automations that will, well, take action in the house automatically based upon me telling it to do this. All right, so I'm going to show you my my automation that happens when I say this. Okay, if I was to try and play this video here inside of this go to training session, it just wouldn't work out for me. So here I'm going to copy and paste this URL into the chat session. Okay, so I'm going to go back into go to training, and I'm going to go to chat, and I'm going to paste this into chat. Control V, boom. All right, so that link, I traced it twice. Let's try this one more time. All right. So if you watch that link, I'm going to give you a minute or two for everybody to click that link and watch the YouTube video of what happens when I say, Alexa, start the escape game. You'll see a couple of things happen. One is this light bulb, or all the lights in the house are going to turn off. This light bulb above the television will turn blue. The front door will lock, and then the television, which is currently off, will turn on and then play a video. All right, so I'll give you a minute to watch that. Okay, I guess you didn't see the link. All right, here, give me 1 second. Jessica, I don't have send to entire audience on my chat list. Can you copy and paste that into the window for me? Oh, I can do it over on this other computer here. Thank you. Thank you very much, Jessica. All right, I was just a second behind you here. Again, okay, so there's that video. Go ahead and click that link. If that's not working, I'll remove these greater than else then. The video is not restricted. Go ahead and you might have to type it in manually. Yes, all right. So it's a little much, right? But I got to tell you, if you're going to build an escape room in your house, there is no way that you are going to convince your friends and family that you are not a nerd. So you might as well own it. Okay. All right. I think some of you are having some trouble with that video. I'll give you another second to watch it. There's another link there if you'd need to type it in manually. All right, so everything that you saw in that video could be done 100% with zero coding, right? That was just go into a web interface. I created the YAML for the switches, and then we go into the YAML and say, all right, when this, or we also have the Philips Hue emulator, so you can control it with your voice. And then we have the action that says, when this trigger occurs, play this video throughout the house. No coding required for any of that stuff, okay? All right. But if you want to build a game, you're going to have to get into some coding, and you're going to have to do some automations. Now, when you download HomeAssistant, you will see this thing that says Python scripts, and you're going to be like, oh, Python scripts. I really want to do Python scripts. That sounds like exactly what Mark would do. No, Python scripts are a huge disappointment. Inside the Python scripts, you can pretty much only do the same things you could do in a YAML script. So you can't import files. You can't do anything other than, well, the same thing you could do with just a YAML configuration. So don't be sucked in by the allure of Python scripts in there. It's probably not what you want to do. What you really want is what's called the AppDaemon. And the AppDaemon is not installed by default when you install HomeAssistant. It is, well, a second module that you download and install. It's written by the same folks that have written HomeAssistant, and it gives you full control of doing full Python scripts where you can import, you can do anything that you can do in Python, you can do in the AppDaemon. You can either do it in asynchronous Python mode or just standard procedural code, the same thing that you would do in the most basic Python programs. Gives you full if-then-else logic that you can do whatever you want. Okay, so this is what the code looks like in my escape game. In order to define a AppDaemon application, you have to define, well, you have to have a class escape game. This is standard that you're going to have in every module. You are going to have an initializer function, and then this line inside the initializer, this is what says what we're listening for on the event bus. So here, I've got this thing that I say, I want you to run the program called, or function, call the function called start game when the input Boolean escape game switch changes its state from old to new, or its old state to its new state to from off to on, I think is what it has. Let me move, yes, from off to on. WebEx was in the middle of it, front of it, I couldn't see it. So when it changes from off to on, then call this start game function. And down here in the start game function, I'm going to record in the logs that the game started. I'm going to record the time because you only got 45 minutes to get out of the room. I'm going to turn back off that escape game switch in the web page so it's ready to go for the next time. And then I'm going to start checking the state of other switches. See, I got all these switches that I can have enabled for the different challenges, so that in theory I could turn off and on certain challenges and have it be a different type of game when you go through it each time. In practice, I just leave them all on throughout the entire game. And so I've got a different switch for each of the different challenges, and if that switch is turned on, then I call a function that is associated with that challenge. So the way it works is you'll have a video very similar to what you saw before. The video will then tell you where to go and find something in the house, such as a puzzle, right? That puzzle might give you a combination or something that might let you unlock a combination to an ammo box that I've got lying around the house. They have these different combination locks on it. Very much the same kind of thing that you might see in a traditional escape room. These combo boxes might let you find keys that unlock other boxes and things like that that are laying around the house. You do things that then trigger some IoT device to take action, which then would turn on the television and play the next clip, which will then walk you through the different challenges. So I kind of have this cycle of going through each of these different steps. So here's one of my puzzles, right? So this one says, excellent job. You show promise, my young apprentice. A hacker must be able to control computers using only their voice. Recreate the pattern at the bottom of this clue. Then things will start to look up for you. Start this challenge. To start this challenge, you must first say, Alexa, turn on hacking beats. Alexa understands lots of commands like turn on downstairs lights, turn on hot away lights, blah, blah, blah. So what happens here is when they say, Alexa, turn on hacking beats, two things happen. It calls the function that starts this puzzle, and at the start of it, it plays dual cores, hack all the things, turns on all the speakers in the house, and plays dual core, hack all the things at a very loud volume throughout the house, which means they're trying to talk to the Alexa and the music is playing really loud and they're trying to scream over the Alexa, and what they're trying to do is get the lights in the house to be configured a certain way, okay? And once they get the lights configured such that they meet these patterns with certain things being off, certain things being on, and one light bulb being set to a specific color, then it advances to the next challenge. So here's the code to do that, right? So the thing that monitors the light pattern, I got a function called light pattern. Inside of it, I've got a sub-function called lights right. It's where lights are right. The lights are right. This will return true when the lights are configured correctly. It's going to look at my center light bulb, and it's going to see if the living room center is turned on. It's going to look at the top light bulb, which is the living room top, and see if that's set to on. If the right is set to off, the left is set to off. The hallway 1 is set to off. Hallway 2 is set to on. And the hallway or living room center is set to a certain RGB color, red. Then each of these variables will be true. The all function is used to look to make sure that all of the items in that list are true. And if they are, then this function returns true. If all the lights aren't exactly right, it returns false. So while the lights are not right, it sits here and it logs the lights are not right. It waits 2 seconds, checks the light again, waits 2 seconds, check the light again. And it'll sit there in its loop until the lights are correct. When the lights are correct, it'll come down to the next line where it'll say, use the media extractor to play on the Sony television this following MP4. And so you saw earlier where I used a YouTube link. These are videos, that I thought to myself, I'll never put this video of me looking this stupid on the internet. So these are all stored on a local server in my house where it plays the videos off on the television. Okay? So that's one of the challenges. But this is the hacker's apprentice, right? So all of the challenges have a hacker theme. Right? So I also tell them that hackers are masters of deception. You remember in Spider-Man that Ned was the guy in the chair, right? The hacker, and he was a master of deception. He had to create a distraction for Spider-Man. So there's, the dancing in the backyard challenge where you have to create a distraction. So in this challenge, I tell them, look, I've got all these motion cameras with motion detection in the house. I'm going to set the motion detection to low, right? And then I need you to go into my backyard and I need you to have a dance party. And then, but you've got to be moving around enough to trigger the motion sensors with the motion sensors set to low. So I then tell it to play Billy Joel's Pressure everywhere. So this begins playing Billy Joel in the backyard throughout the house. I get the count on the number of camera alerts that I have, and then that's my start count and the current count. And then while the start count is equal to the current count, I'm going to update the current count. So if the count doesn't change, then it'll sit here in this loop again, recording the camera count, and sleep for 2 seconds. When it finally does record a change, it will log that dancing was detected, dancing finished, and then it'll make an announcement in the house. Right, so the announcement function, again, turns on the speakers and then uses a text-to-speech function to make announcements in the house. It says, warning, bad dancing detected. Next clue will play in 60 seconds. And then it sleeps 60 seconds, and then it plays the next clue in the house. I had this idea of using these little Bluetooth buttons. So these little Bluetooth buttons by Flick, you can see them on the screen. I've got one in my hand here. These are really cool. They're little Bluetooth buttons that you can stick on your refrigerator or anywhere you want to. And when you push the Bluetooth button, you can have a Bluetooth receiver that knows the button was pushed, and it can send devices and triggers onto HomeAssistant. So I had this idea of using these buttons as an anchor challenge, right? That an anchor challenge, you can think of that as you go into an escape room, and it gives you a puzzle where you've only got like one piece of the puzzle, and you have to collect up all the other pieces of the puzzle throughout the entire game and put them together. And once you solve that big puzzle, then it lets you out. So my idea was I would have these buttons that would be hidden in ammo boxes and scattered throughout the challenges. And ultimately, as you'd have to collect all the buttons to play a game of Simon, right, where lights would blink a certain color, and you have to repeat that pattern in the light bulbs. And so, initially I'd have 2 of these buttons, and you play Simon for a little while, and then it would get to a color that you don't have, and you'd I got to go and solve more puzzles to get more buttons. That was the idea. But as it turns out, I haven't implemented this for a couple of reasons. One reason is because, it's Bluetooth. And so I would have the Bluetooth receiver there to receive these buttons, and it worked okay, but the problem was that, well, people would carry the buttons with them and go elsewhere into the house, and then they would start pushing the buttons when they were out of range of the Bluetooth. And I've got some ideas of having a place where they mount the buttons or something to bring them back into range of the Bluetooth receiver, but it just fell by the wayside. So at the moment, all I got for this button is, here's my button. If I push my button at the moment, here, let me push my button. Here, what's this doing? Okay, here we go. Oops, hold on a minute. I got it set up on my phone. All right, and the moment, it's not doing anything, right? Come on. At the moment, it's not working. So I can't show it to you. What? Why doesn't this work? Yeah, let me start this over. Let me restart the Bluetooth app. Okay. Yeah, okay. All right. So isn't that exciting? So at the moment, this $50 Bluetooth button is, yeah, it's an electronic whoopee cushion where I push the button and it makes fart noises. Okay. Now I know what you're thinking. You're like, wow, we waited all that time for that. Well, see, here's the thing. The immaturity of flatulence is actually inversely proportional to the amount of automation used. So it's exactly opposite of the whole romantic gestures. Actually, if it's really immature if you have no automation involved in something, but the more automation you add, Bluetooth enabled fart noises, that's pretty good. And of course, medical devices for the flatulently challenged would be, that's not immature at all. All right, so it's inversely proportional to those things. All right, so other challenges I've got in there. I've got actual hacking. They do some actual hacking. So I have the video points them to a web page in the house, and they go to the web page, and on the URL it says some IP address #numghosts equals 6. And when they go to that web page, they get presented with Pac-Man, and there are 6 ghosts in Pac-Man. And so I figured, well, they'll make the connection that there's 6 ghosts, and they went to a URL numghosts equals 6, and somebody will think to change these things from 6 to 3. But I did mention that this was a non-technical audience, right? I am surprised every single time that I do this with non-technical folks, and even some technical folks, even some people that, well, I consider to be really smart, that would come over and not think to change the number of ghosts to something other than 6. Well, I think that oftentimes people were just too distracted by the awesomeness of Pac-Man that they'd want to play Pac-Man as they did this. But that's it. Another challenge, hackers are OSINT experts. So I tell the hackers, I tell the players, hey, there's a switch inside my house. Remember I told you that switch that's got some password in there? There's a switch in my house that is named after Mark's high school mascot and his wife's record-breaking time in 1988. So she had held a record in 1988. And so I have them do some OSINT on us to figure out what those times were. And then they have to say, turn on mascot name time. And when they get both those items, they can turn on the switch with their voice. And when they do, that triggers the next clue. The thing is that in my house now, because, well, everything it can see, right? It sees, it knows what the volume is on the television, it knows what channel your televisions are on. It knows the temperature on your thermostats. It knows the number in your sleep numbers. It knows which channel what buttons you're pushing on your remote control. I just see combination locks everywhere, right? Everything in my house is now a potential combination that I can have people discover and then type and then move forward on the next challenge. There's different ways I can communicate challenges. Like I could change the television to a specific channel, and that channel be a combination that they have to type on the system, and then or toggle back and forth between 2 channels, and then those 2 channels somehow represent these combinations. Or I could set the temperature in the house to a specific number, which is a combination in the house. Everything is now, I see either ways to communicate or collect combinations from people to unlock these boxes. So here's some lesson learns, right? Don't do the things that I did. So remember, it's still your house, right? So some of these challenges that I created may have been bad ideas. Okay? Having people go into my backyard and do the backyard dancing thing in the rain, and then bringing all that mud back into the house, that one didn't work out well for me. So that's when we added those switches in to turn off and on certain challenges. So if it's raining now, I won't have people go into the backyard and do things outside. Maybe it was a bad idea to ask people to do some open source intelligence gathering on my wife. I don't know, maybe that was a bad idea. It didn't work out well for me either. Let's see. Oh, I had a challenge once where in order for people to advance, they had to actually go and lie in my bed, and that one didn't work out for me either. So just keep in mind that you've got people in your house that are going to live there that may not want people climbing into your bed at night and things like that. So these are some challenges that I've had to eliminate. So what do you need to get started, right? So well, you need some Python coding experience to do a game, right? Most of the automations, I mean, think about this. With just downloading the software and doing configurations through YAML, you can completely do an automation that knows when you come into the house based upon your MAC address, right, showing up in the wireless. Or it will also interface with Apple's "Where's my iPhone" or "Where's this thing," so it can know where you are, and you can have it set the temperature in the house when you come within range of your thing. But that would require an IoT device. If you just have a television set that is on your wireless network or plugged into a wired network, if your television is on the wireless network, if that's the only IoT device you have, you can have it set up where when you come home, right, it detects that your phone is now on your wireless network and it turns on the television to a certain channel. Or time-based events, if the sun is up and certain things happen, it can go and monitor websites, right, and monitor websites, and so look at the COVID-19 infections. And if the COVID-19 infections drop below 14 a day, which here in the state of Georgia, we just dropped below 14 a day of new infections, or some milestone was pressed today, it might not be 14, that it sends out an alert that says it's safe to go outside of your house, maybe by blinking lights in your house or something like that. The ideas of what you can come up with, right? There's no end to the end of this. Really, all you need to get this going is HomeAssistant.io. You can download that module. You can put it on the laptop, and it will find your devices and let you configure them through a WAN interface. You might be surprised by the amount of IoT that you have in your house already. All right. So that's my talk. If you'd like a copy of the code, right, that I have for the escape game, or most of it, I don't put it all out there for reasons. Okay, but if you'd like a copy of it, I'll share most of the code with you. You can reach out to me on Twitter. I'm at Mark Baggett. My direct messages are open, so you don't have to follow me. You can just send me a message, and I will respond back with a copy of the code if you'd like that. And with that, we have about 10 minutes left that I can take questions. So if you have any questions for me, go ahead and type those into the question box, and I will try and answer those. If there aren't any questions, just do me one favor before you take off. I think Jessica is going to drop an eval link, or probably already did drop an eval link into the chat window. If you wouldn't mind clicking that and filling that out, if you've been to anything SANS before, you'll know how important those are to SANS. So appreciate it very much. It would take just a minute to fill that out. And with that, I'll answer some questions. Have you done any testing on how much of the information it collects is sent outside of your network? Excellent question. So it is one of the design goals of HomeAssistant, right? Of course, I've got my perimeter on the firewall. I've got my firewall locked down where every device that inside my network that wants to talk to something on the internet, I'd have to open up those destination IP addresses, right? And every time I bring in a new device, it always wants to phone home to this callback service so they can subscribe to these things. And but one of the goals of HomeAssistant is to replace all of those web pages on the internet. They've got a service that what happens is these different devices will, anything that they can, either through man in the middle or spoofing different services and appear to be those services, they will keep all that stuff on your local internet. And then you can stand up inside of a cloud service. This thing, it's called Casa, something I skipped over this slide. It is called, let me find it, Nabu Casa. Okay, you can either use Nabu Casa, which is a paid service, where you stand up this small HomeAssistant agent inside your network, and then one on the cloud. The thing on in the cloud talks to everything that's out there, and all of these devices talk to the HomeAssistant thing internally. So it's like one connection outbound, or it minimizes those. It hasn't been one in my experience, but it has reduced the number of connections that I have to have outbound. And it's through a specific API, so I can see exactly what's going on. So it actually improves that if you have these IoT devices anyway. Let's see. There are some other questions. Let me scroll back up a little bit. Awesome. Friends from church must have been like, we thought we were just gonna. Yeah, they weren't really expecting the game. How do you find a wife to accept that? Yeah, my wife is awesome. Do you hate it when live demos don't work? I do hate that. Let's see. Love how you think about the challenges. Have you done any tests? Okay. When can you get cheaper, or where can you get, so there are cheaper IoT devices. I've seen some cheap light bulbs, and I found some cheap switches that I can use to, it's just like an IoT plug that sits in between the electrical outlet and these things that you can turn off and on. And they're by Smart Home, and they're relatively cheap. It's like a $5 thing, but I am sure, right? Well, I'm not sure, but it's all got Chinese firmware on it and stuff like that. So you're taking your chances, I guess. Let's see. Great webcast. Thank you for time. Thank you for coming out. I don't know if you've answered this already, but I only got here. Can you call HomeAssistant as a platform to manage all? Yeah. So HomeAssistant, they've got it as a Raspberry Pi operating system. So I think they call it Raspi. No, Raspi, HomeAssistant Raspi, or something like that. You can just install it on a Raspberry Pi. You can install it as a Docker on a system, or you can download it as a Python module. So they've got lots of installation options. You can see it at homeassistant.io, and is intended to be a platform to manage everything that's on your network. How many devices, more or less, can it have on the system? I don't know that there's a limit to the number, but I'm sure that there is, but I haven't even come close to it. Will the recording be available? Yes. How much of your IoT traffic is in the house is encrypted at TLS and things like that? Well, I think it's about internally on the network. I think all of the external services that go on the internet, I believe, are encrypted. The one thing that I know is not encrypted on my internal house is that custom IoT device that I found, because the Legrand HQ, but that never leaves my network. It stays internal. I know that doesn't make it okay, but let's see. Thank you, Mark. You're welcome. Okay, I think that's all my questions that I've got there. If there aren't any other questions, well, we'll wrap it up. Thanks for coming out. Actually, we got 8 more minutes. 8 more minutes. If you joined late, I'm going to use my last 8 minutes to show you, once again, my movies written in Python. Okay, so there's a lot more people here than there were at the pre-show. I'll go through the movies written in Python one more time, and give you guys a chance. If you've already saw these, well, I guess you can't see the answers to this, so I'll just go through them. All right, what's the name of this movie written in Python? This is I got another question. How do you protect your MAC address in internet? This one is Captain America, the First Avenger. The answer is your MAC addresses aren't going to go out on the internet. They're going to stay locally on the internal network. Okay? It's when it connects to the Wi-Fi here in the house that MAC address shows up on the CAM table on my internal network. This one is Captain America, the First Avenger. How about this one? It's a 1955 movie. Movie 1955. You can type your answers into the questions if you know. Singing in the Rain, very good. Singing in the Rain. How about this one? 1975, movie released in 1975. Here we import the sys module. We look for sys.version.info, and the version of Python is Monty. Then it is Monty Python and the search for the Holy Grail. Here we use the regular expression search function to look for Grail in the quest, and we find it, right? Here's the results. It's in the 95th position in the results. Our 2011 movie, 2011. Uncompile. We pass it some Python bytecode, and it gives us back something that says cast is Jake Gyllenhaal, Michelle Monahan, and then it prints the cast. No, it's not Transformers. What is this thing giving me back? What is this when I give it some bytecode? What is uncompile going to give me back? Beat it bytecode, and when I get back down here is the actual program itself, also known as, it is source code. The source code is a Jake Gyllenhaal movie. Yes, excellent job. 1999 movie. Movie 1999. It is The Sixth Sense, right? We got a list here of senses. When you pull things out of a list, you give it a position. This is position 0, 1, 2, 3, 4. So the fifth, position 5, is The Sixth Sense. What is the name of the conference or event you host annually again? I'm one of the organizers of BSidesAugusta. BSidesAugusta in Augusta, Georgia. Thanks, Thomas. All right, that one is The Sixth Sense by Bruce Willis. 1991 movie. Oh, I don't like that one. Okay, 1993 movie. 1993 movie. Who's going to type it first? And the winner is James. James wins The Last Action Hero. So we got a list of action heroes. Sylvester Stallone, Chuck Norris, and Arnold Schwarzenegger, who is in position -1, which pulls out the last action hero. Okay, 2002. Here, this is some advanced Python code. We're creating a special type of error or exception, right, called the UCAN exception. We have a function called me that checks on identity. And if the identity is not right, it raises the UCAN error. Very good, James. This one is catch me if you can. Right? The error is a UCAN error. We wrap the me function inside of a try except block. If an error occurs, this will catch the UCAN error on function me. This is catch me if you can. Catch me if you can. 1990. 1990. We got two lists. The map function is used to, well, join together the items from each of the lists by zipping them. So it does a zip where it takes the first item in the list, puts them together, second items in the list, puts them together, and so forth. So what do we get as a result of this? We get a new list that contains 3, 2, 1. It contains dances, the hustle, the twist, the Charleston, the renegade, and salsa, with wolves, the gray wolf, the werewolf, the teen wolf, the boy who cried wolf, and the big bad wolf. This is dances with wolves. All right, 1999. This is going to create NumPy is used to create arrays of arrays, or grids, also known by another name. So it's going to create a 10 by 10 array of arrays. In position 1, comma 1, it puts the 1. It is the matrix. Excellent, Sir Addison. Well done. Okay, position 3, comma 1 is Trinity. Position 5 is Agent Smith, and 4, 2 is Cipher. Each of those are in the matrix. All right, 2010. 2010, we have a dictionary called Teams. At the key of C, we have Cowboys. Key of R, we have Redskins. Key of A, we have Astros. Key of B, we have Vikings. And then we do a get to retrieve the A team. Very good, Shane. Shane got that one first. The A team. 2017, what movie is this? Excellent, Dan. Dan got that one first. It is Ghost in the Shell. We're opening up a copy of bin bash, which is the Linux shell. We're reading it in as a binary byte string. Then we're going to look to see, is Casper a ghost in the shell? And we get back true. There is a ghost in the shell. 2004, this is our last one. We import the date time function as date. For import datetime date, we import the random function. We then have a function called getFirst, which takes in D1 and D2 and returns the minimum one of D1 and D2. We then have a for loop, which says for I in range 50, we choose a random date assigned to X, we choose a random date assigned to Y, and Wade comes up with 50 first dates. So it's going to choose 2 random dates, call getFirst to figure out which one is first, and print that. So this is 50 first dates. 50 first dates. So, okay. All right, it is 9:31, and this is repeating back to the end. So thanks again. I appreciate your time. I hope you guys are staying safe. Hope you're enjoying SANS free at night talks. And one thing to point out, look for a free workshop that I'll be doing. I think it's on May 19th. We're going to be doing a free workshop where we're going to be using Python to geolocate IP addresses and wireless networks. It's going to be a 2.5-hour workshop where the intention is really to teach you some geolocation techniques. So keep an eye out for that coming up soon. And that's it for me. Thanks again for everybody. If you didn't fill out an eval, please take a moment to do so, and have a nice night.